Good morning dear students. In this video we will show that the equation x cube minus 3x square y plus 2xy square dx minus x cube minus 2x square y plus y cube dy is equal to 0 is exact, and we will find the solution of the given equation if y is equal to 1 when x is equal to 1. So let's see the solution. Here m is equal to x cube minus 3x square y plus 2xy square. This is our m, x cube minus 3x square y plus 2xy square. So when we will differentiate it partially with respect to y, 3x square will be treated as a constant and 2x will be treated as a constant. Now, so partially differentiating m with respect to y, we get del m by del y is equal to del y of x cube minus 3x square y plus 2xy square. Further, we can write in the next line del m by del y is equal to del y of x cube minus 3x square multiplied by del y of y, because 3x square is treated as a constant with respect to partial differentiation y, plus 2x multiplied by del y of y square, because 2x is a constant, so it is taken out of the partial differentiation respect to y. Or further we can rewrite it as del m by del y is equal to 0 minus 3x square multiplied by 1, because del y of y will give us 1, and plus 2x multiplied by 2y, because del y of y square will give us 2y, and del y of x cube is equal to 0, because x cube is a constant with respect to partial differentiation y. Now we can further simplify it as del m by del y is equal to minus 3x square plus 4xy. So we have named it as equation 1. Here our n is minus of x cube minus 2x square y plus y cube dy. We have to always remember, read it carefully, that we have to take this minus with this entire part, this n part, because our equations, exact equations, are always written in the format m dx plus n dy, but here it is minus, so we have to take the minus as n. So n is equal to minus of x cube minus 2x square y plus y cube. Minus is multiplied with this entire part. Now partially differentiating n with respect to x, we will get del x of minus x cube plus 2y is taken out of the partial differentiation, because 2y is treated as a constant here. So del 2y multiplied by del x of x square minus del x of y cube. Further, next line we can rewrite it as del n by del x is equal to minus 3x square, because del x of x cube will give us 3x square, plus 2x multiplied by 2y, because del x of x square will give us 2x, minus 0, because del x of y cube is 0, as y is a constant here in partial differentiation with respect to x. Or which can be rewritten as del n by del x is equal to minus 3x square plus 4xy. We have named it as equation 2. So from equation 1 and 2 we can easily see that del m by del y is equal to del n by del x is equal to minus 3x square plus 4xy. Hence our given equation is exact. So first part is proved here. Now we have to find the solution of this given equation when y is equal to 1 and x is equal to 1. Here the given equation is exact, so integration m dx is equal to integration x cube minus 3x square y plus 2xy square dx, which can be rewritten as integration m dx is equal to integration x cube dx minus 3y is treated as a constant, because y is treated as a constant in this integration with respect to x. So minus 3y multiplied by integration x square dx plus 2y square is taken out of the integration as y is a constant. So 2y square multiplied by integration x dx. Integrating x cube dx, we will get x to the power 4 by 4. Integrating x square dx, we will get x cube by 3, multiply it with minus 3y, plus integrating x dx, we will get x square by 2, multiply it with 2y square. So further we will get integration m dx is equal to x to the power 4 by 4 minus x cube y plus x square y square. Now we will find integration n dy. Integration n dy is equal to integration minus of x cube minus 2x square y plus y cube dy. Now, which can be further rewritten as minus x cube multiplied by integration dy plus 2x square multiplied by integration y dy minus integration y cube dy, because in integration n dy x is treated as a constant. So x cube is taken out of the integration and 2x square is taken out of the integration, as these are constants. So integrating dy, we will get y, multiplying it with minus x cube, we will get minus x cube y. Integrating y dy, we will get y square by 2 and we will multiply it with 2x square. And integrating y cube dy, we will get y to the power 4 by 4. So here the solution is integration m dx plus n dy is equal to x to the power 4 by 4 minus x cube y plus x square y square minus y to the power 4 by 4 is equal to c. That is nothing but we have added these two parts. X to the power 4 by 4 minus x cube y plus x square y square minus x cube y plus 2x square y square divided by 2 is equal to x square y square minus y to the power 4 by 4. Now from both the equation we have repeated terms x cube y and x square y square, and we won't write these repeated terms twice. So further we have taken it only once. So we have rejected the repeated term, and which have given us x to the power 4 by 4 minus x cube y plus x square y square minus y to the power 4 by 4 is equal to c. Now we have to find the value of c when x is equal to 1 and y is equal to 1. So putting x is equal to 1 and y is equal to 1, we get 1 to the power 4 by 4 minus 1 cube multiplied by 1 plus 1 square multiplied by 1 square minus 1 to the power 4 by 4 is equal to c, which will give us 1 to the power 4 by 4 minus 1 plus 1 minus 1 to the power 4 by 4 is equal to c, or c is equal to 0. So now the required solution is x to the power 4 by 4 minus x cube y plus x square y square minus y to the power 4 by 4 is equal to 0. On simplification we get x to the power 4 minus 4x cube y plus 4x square y square minus y4 is equal to 0. So this is our required solution. Thank you.